Hey, grade 12s. Thought I'd make a few videos around calculus, starting just by giving you an introduction on the type of questions that are asked in this chapter. These are the mark allocations for what we've seen over the past few years in your final exam papers, as well as trials and June. And it always starts off with the first principles question, where it asks you to find the first derivative using first principles. And it's the long method that you just kind of have to get into your head. Luckily, they give you the basic formula for it, so if you forget it, you can always go have a look. About 6 marks, 5-6 marks. The second part of the calculus question in your exams is finding the first derivative, and here they allow you to use your shortcut method without having to do the long first principles route. Also about 6 marks, they usually ask 2 questions there. The graph question of cubic graphs, they either ask you to draw one, or they give you one, and they ask you questions on it. Up to 15 marks. Be on your toes for some good questions there. And then they usually end off with the optimization, maximization, rate of change, instantaneous speed, those sorts of questions at the end for about 7 marks. So I'm just going to make a few videos just talking through these 4 areas and giving you a few examples of each of them. Okay, so the first area that I'd like to speak to is the first principles. Okay, so as I said earlier, it's the longer method, and you're going to have to do one of these in your exams. Okay, there's the formula that says find the first derivative, or f dash x, f prime x, whatever you want to call it, is equal to the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. Now remember, we would have established this formula by looking at almost the rate of change as well as the gradient formula. Okay, I think you may have had an example like this where they drew, let's say, an exponential graph, and they wanted to work out what the average gradient between 2 points were, and eventually it worked out that we wanted to find the gradient at a point. Now that would have caused an issue because you would have been dividing by 0. Okay, so now in order to get around that whole dividing by 0 concept, we've worked with this formula now, where you use the original formula or function, but you add a small part h on top of the fx, and then you minus the fx, the original formula. That is in effect your change in y, and then change in x is the small difference we call h. Okay, so this whole formula, working out the first derivative, you remember, what does the first derivative tell you? I'll probably repeat myself later. The first derivative gives you the equation that you will use to find the gradient at a point on a curve, right? Or the gradient of the tangent at a point on that function. Okay, so let's go look at these 2 examples that I've got for you. I've seen in the past they prefer to do a quadratic function in your questions, and this is just a straight line function, obviously, which is not as popular. But I thought I'd start with this basic fx is equal to 5x plus 8. So we start by writing f dash x, or f prime x, equals. We always need to write the limit as h approaches 0. You have to write that, you lose a mark if you do not. Right, so remember the formula f of x plus h. So here's my fx. So in the end, in my numerator, I will minus the whole of fx, right? I'm going to minus 5x plus 8 entirely. Let me just zoom in here a little bit here to assist you to see what I'm doing, right? So I'm going to minus 5x plus 8 at the end, but that means I start my numerator with what? 5 of, now instead of saying 5x, we're going to say 5 of x plus h, right? The x is now replaced with an x plus h. And then what's left in this function? Plus 8. So first part, 5x plus h plus 8 is replacing that f of x plus h. We then minus the original function, 5x plus h, and that's our numerator done. The very boring denominator is simply the h. Okay, moving to the next line. I'm not going to rewrite the f dash x all the time. I will now. And then we have to rewrite limit as h approaches 0. Let's times the 5 in. We're going to get 5x plus 5h. We're going to have a plus 8 minus 5x minus 8. Right, numerator done. All divided by h. Great. Let's keep going. What do you notice cancels out? The 5x there, the 5x there cancels out. The 8 over there, the 8 over there cancel out. So I'm left with 5h over h. Right? At this point, I can cancel my h's. So now, what is this saying? What is the limit as h approaches 0 of 5? Now, because the h's have cancelled out, our answer is simply 5. Okay, now this should make sense because the gradient of 5x plus 5x plus 8, the gradient is 5 everywhere. Because it's a straight line, the gradient is not going to change anyway. So we expected to get 5 as our answer anyway. Okay, let's look at the second one, which is the more likely of questions that you'll get involving a square. Right, so the first step, once again, f dash x equals, and we write the limit as h approaches 0. Now remember the formula, f of x plus h. So let's start with the side 2 of what? Not just x squared, x plus h all squared, minus, not just x plus h. Right, so that's taking care of the first part of my numerator, and then I minus fx. So I minus the whole of fx, which is 2x squared minus x. Great. Now, divided by h, obviously. Now it's just a case of cleaning up the numerator a bit. So firstly, let's leave this 2 for now. Let's FOIL out that bracket, which will repeat itself, 2 of those brackets, x squared plus xh and another xh, so 2xh plus h squared, right? Minus x minus h, I've times that negative sign into the bracket, and then lastly, to get rid of this bracket, minus 2x squared and a plus x. Okay, then all divided by h once again. Let's times in by the 2 at this stage. We're going to get 2x squared plus 4xh plus 2h squared, and then minus x minus h minus 2x squared. I'm running out of space here, and plus x. Okay. Divided by h. Now let's look carefully as to what possibly can cancel out now. So I've got 2x squared, which is gone with that minus 2x squared. I have got a minus x over there, which cancels with my plus x over there. What is left now in the numerator? I've got 4xh left, which can't cancel with anything. I've got plus 2h, and I've got a minus h all over h. In order to cancel the h at the denominator, which is ultimately what we'd like to do, we're going to take out a highest common factor of h at the numerator. So what is left? 4x plus 2h minus 1 divided by h. Cancel the h's away, and now it's equal to the limit as h approaches 0 of 4x plus 2h minus 1. At this stage, we can make h equal to 0. That would mean that this middle term is going to disappear, it's going to head to 0, and therefore leaving us with now our answer, so we don't write the limit anymore, we're reaching the limit as h approaches 0 of 4x minus 1, and there is our answer. Okay, I've written here at the bottom of my page here, remember, always check using your shortcut. Okay, and just to explain what I mean with that, our original function here was 2x squared minus x. And we have worked out now that the first derivative is 4x minus 1. Okay, so just to make sure that that does indeed become that as a first derivative, let's use our shortcut. Our shortcut means the 2 times by this 2 gives us 4x, and then the 2 is reduced by 1 to give me 1, obviously, right? This is a term involving just a simple minus 1x. So the 1 at the top there would be times by that negative 1 to give me negative 1. And then if I reduce the 1 by 1, I'm going to get x to the power 0, which is 1. So our first derivative is 4x to the power 1 minus 1, which is indeed what we got by using first principles. Okay, so using first principles, you should always get the right answer because you can always check to see whether the shortcut confirms your answer. Okay, please remember notation. I've seen the past papers, you have to write the notation correctly in order to get the maximum 5 or 6 marks. Okay, so that's first principles for you. Let's just end off with that formula. Very important formula. please do your best to memorize it and apply it successfully. Great. The next video, I'm going to be introducing finding the first derivatives using shortcuts.